For question number 3, let's look at this situation here. We're going to take the same amount of money, call it P dollars, and we're going to regularly deposit it into some interest-earning account at the end of equal periods of time. So suppose we take like $100 and deposit it regularly at the end of every month into some interest-earning account. Now, that sequence of deposits is called an annuity. And the amount of the annuity, or the future value of the annuity, is the final amount in the account at the end of all the time periods. So here's our question 3. Let's relate it back to what we just did right up here. So at the end of each month, for 24 months, we're going to take $400 and put it into an account that pays 8% interest compounded continuously. All right, so get the idea. So it's like maybe at the end of every month, you take your $400 and you put it into some account. Account pays 8%, and you're going to do that for 24 months. So what we want to do is find the future value of that account. So how much money will we have at the end of 24 months? So we have an integral that does this for us. Here's what it is right here. We derive it in the textbook. You can look at that if you like, but I'm just going to use it for this problem here. So I'm going to write this integral. I'll do it up here. It says A is equal to the integral from 0 to n. Now, n is the number of payment periods of P. That's the principal. That's how much you're putting in at the end of each time period. E to the RT dt. So for our problem, we're going to have, this is going to be equal 0 to 24, right? Because we're going to have 24 payment periods. We put our $400 at the end of each month. Now, e to the interest rate, 0.08, right? 8%. T dt. So this is an exponential. We know what to do. It's going to be the 400, and then we're going to get e to the 0.08t over 0.08, evaluated from 0 to 24. Now, this part right here, 400 divided by 0.08, that's 5,000. So this is going to give us 5,000 e to the 0.08t from 0 to 24. All right, let's put in the upper and the lower limits here. So we're going to have 5,000 e to the 0.08 times 24 minus, now be careful here, is 5,000 e to the 0.08 times 0. Now this part here, in the past problems, that's just been going out. But look what you've got here. 0.08 times 0 is 0. E to the 0 is 1. 1 times 5,000 is 5,000. So this is going to be minus 5,000. Now we have to compute this. So look at this integral. See what we have, see what we need. Now, we have n. N, that's the number of payment periods. We're doing this for 24 months, so n is 24. P, the principal, that's the amount we're investing at the end of each month. That's 400. Now R is the annual interest rate, which is 8%, but we're investing this every month. So our interest rates are going to be divided by 12. And I'm just going to leave it as this fraction, let my calculator do all that work. Let's just be sure this makes sense here. What is this R? Come down here to the definition, and it says that R is the interest rate per time period, and our time period is every month. So that 8%, that's per year, but we have it every month, so we need to divide that by 12. So our integral is going to go from 0 to 24 of 400 times e. Now I'm just going to write it like this. 0.08 divided by 12 t dt. And when we find that antiderivative, we're going to get 400e to the 0.08 divided by 12 over 0.08 divided by 12 from 0 to 24. So I'm going to do something with this right here. This is going to be 400 times 12 over 0.08, and then e to the 0.08 divided by 12 from 0 to 24. So this will give us 400 times that 12 over 0.08 put in the upper limit, there's a t here, right? To the 0.08 over, I forgot my t's, 12 times 24 minus 400 times that 12 over 0.08 e to the 0.08 over 12 times 0. Now, this part right here, look at this part over here on the right. You got e to something times 0. So 0 times this is 0. E to the 0 is 1. 1 times this number is just that number. So what we need to compute now is this and then minus the 400 times 12 over 08. All right, and when I did that carefully on my calculator, I got this number right here. Let me look for it again. I got 10,410.70. All right, so what we're going to do now is we're going to take $400 a month, put at the end of each month, put into an account that pays 8% compounded continuously, and at the end of 2 years, we're going to have $10,410.70.